So the code challenge that you're about to do comes from a really interesting phenomenon that you might find in London. I live in London and it's well known as a big financial district. So when you head over to the city or the financial area in London and you go into a restaurant, you might see a strange thing happen. You might see a whole bunch of people in suits who look very much like the financial banker types. At the time when they actually need to pay the bill, you see everybody pull out their business cards and put it into a bowl. So what's actually going on here? A friend of mine told me apparently there's this game that the rich banker types play where it's kind of like Russian roulette with the bill. So everybody puts their business card in, and the person's card who gets picked out has to pay for everybody's bill, which is kind of crazy, but then again, it's finance. So in today's code challenge, this is what we're going to replicate with code. So go to day 4.2, who's paying? Then you'll see that I've got some instructions there for you and some starting code. Now, the idea is that once you've completed the challenge, you should be able to type in a whole bunch of names as an input with a comma and a space separating each name. And then the code will pick a random name from the ones that you've given it and tell you who is going to buy the meal. Now, you'll remember from the previous code challenge that these two lines of code are there so that we can test your code. So when you run it, you'll have to type in a random number as the seed. But in addition, we've got these two lines of code that you might not have seen before. Now, this is something called split. And this allows you to split a string into separate components based on some sort of divider. So in this case, notice how it says hello, comma, from, comma, as Python. Now, if we use the split on this string, then it will divide it up into a list and separate out all the words that are divided by this split character, which is the comma. Now, similarly over here, when we give the input, it's going to be in the format like this. Everybody's names separated by a comma and a space. So now if we use the split on a comma and a space, then it will take out the comma and the space and it will put everything else as separate items inside a list. So what I recommend doing before you get started writing the actual code is to test it out. So print out what names actually looks like. So if we go ahead and run this code and we type a seed number, just any random number, and then we type a bunch of names separated by a comma, so Angela, comma, space, Ben, comma, space, Jenny, and then hit enter, then we hit the line where it prints names. Now names, as you'll see, is now a list with all the names that I typed in. And while previously they were separated by a comma and a space, they are now all individual items in a list. The idea is that you've got all of these items inside a list. How can I pick a random one out of it using a random index based on the number of items in the list, which of course can change? And then how can I get a random name as the output and then print so-and-so is going to buy the meal today? So have a think about it, have a pause, and then see if you can complete the challenge. All right, so you've already seen that when we type a whole bunch of names separated by a comma and a space, the lines of code on 7 and 8 is able to turn that into a list, and we end up with a list of names. So now that we've got the list as a starting point stored inside names, how can we go about generating a random name and picking it out of the list? Well, we know that we can pick a item from the list by adding a set of square brackets and then a index number. So in this case, it should print the first item out of the list, which is going to be just the word Angela. And I can run this to prove this to you. you can see that names is a list of all the names, Angela, James, Ben. Names at position 0 is Angela, the first item. Now, how can we get a random number to replace that number 0? Well, we could use our random generator. So we've already imported the random module, and we can say random.randint, and then we can specify the start and end. So the start is probably going to be 0, because that's where we start counting with our lists. But what is the end? Well, the end should be the position of the last item. But how can we know that position? What is that X going to be? Well, what if we got hold of the number of items in the list? So do you remember how previously we learned about the len function? Well, the len function can be used to get the number of elements in a list or the number of characters in a string. And if you take a look at this Stack Overflow question, then you'll see it in action. All that we have to do to get hold of the number of items inside this names list is to write len parentheses, and then inside we put names, and now we can either store this or print this. Let's go ahead and first print what the value of this is going to be. Let's go ahead and comment out this line of code, and then run our code, type a random number for the seed, and then give everybody's names separated by a comma, Angela, Ben, and James. Hit enter, and you can see that this line of code on 13 has printed 3. So the length of my names list is 3. There's 1, 2, 3 items inside that list. So now that we've gotten hold of that, then we can probably use that number that comes from this len function inside our random generator, because we know that we can use this to get the total number of items in list. So in this case, that would be 1, 2, 3, 4, 5. This last item is not at position 5 though, right? It's at position 0, 1, 2, 3, 4. So we always need one less than the total number of items. And the range of random numbers we would want is num items minus 1. Now, this line of code will allow us to generate random numbers between 0 and the last index. So, for example, if we had this list, then we would need the random numbers to be 0, 1, 2, 3, and 4. Which is exactly what this line of code is going to do. And I can store that inside a random choice variable and print my random choice. So if I run the code again, and it prints 1 this time, but the next time it might print 0 or 2, because those are all the possible choices for a 3-item list. So in this case, the num items is equal to 3. The random choice is going to generate a random number between 0 and 3 minus 1, which is 2. So the random numbers could be 0, 1, or 2. Now we can use that number to actually get hold of a particular item in our list of names. So we can say names, square brackets, and then we're going to use the random choice to get hold of the random item. And then we can go ahead and save this as the person who will pay. And we can print person who will pay plus is going to buy the meal today. So now let's go ahead and run our code again, and then give everybody's name separated by a comma. And then it says James is going to buy the meal today. But if I run this code again using a different seed number, which is going to generate different random numbers, then in this case, well, Ben is going to buy the meal today. And now we know that we've completed the challenge. Now, you'll notice that in the instructions, I told you that you're not allowed to use the choice function. And the reason for this is because if you search as Python and you search for the random module and you scroll down, you'll find that you can actually generate random items from a sequence, such as a list, by writing random.choice. And it will actually pick an item from that list. So let me demo what our code would look like instead. Instead of needing all of these lines of code, all we have to write is random.choice, parentheses, and then we put our names list inside. And now it will do exactly the same as before, but with far less code. But this, of course, doesn't test whether if you've understood how indices work with lists and whether if you're comfortable with the idea that the last index is actually one less than the total number of items because we start counting from 0. I've made it a little bit harder than it needed to be, just to see how good a grasp you have on lists. Now I hope that you managed to complete this challenge. If not, don't worry, go back to it and see if you can replicate the logic that we talked about just now. And if you really struggle visualizing what these lines of code is doing, then you can always pass it through Thonny and use the debugger to step through it one step at a time and see what's happening at each stage. Now, on the next lesson, we're going to see some more advanced parts of lists in action, namely how to nest lists inside other lists. So for all of that and more, I'll see you on the next lesson. Now, when you're working with lists, one of the most common errors you'll come across is something called the index out of range error. In fact, by this point, you might have already seen it. Now, what does it mean though? Well, let's take our states of America and let's delete the line where we added Angela Land and Jack Bauer Land. So we go back to the original. And you might remember that there are 50 states in America, but if you don't, because you're a programmer, it's as easy as writing len and then passing over the states of America, which will print 50. So now that we know that there are a total of 50 items in this list, and remember, because we start counting from 0, Hawaii is actually at index 49. So if we print States of America and then we try to get the item at 49, we hit print, you'll see that we get Hawaii printed. Now, what if we went one beyond that? What if we tried to get the one at index 50, somewhere out here? What do we get instead? Well, we get an error. It's called an index error. And this is because it's beyond Hawaii and there's nothing there, as we can see with our own eyes. But when you're working with large lists and you're not always looking at the data, then these errors can be a little bit more confusing. Very frequently, when you're working with lists, you'll end up with an off by 1 error. So it's unusual that you'll try to get something at index number 90 because that's just way beyond your list size. But very frequently, you might end up in a situation where you have some sort of value, say number of states equals len, and then we pass over the states of America. So this is going to be equal to 50. And then we pass that inside here as the index num of states. And then we hit run and we get the same error, right? On line 16, where we try to get hold of this index in this list. It's again, list index out of range. And this is an off by 1 error because all we need to do is just simply -1 so that 1 becomes 0 and 50 becomes 49. And then we get rid of that error. Now, it might be easier if we work with something a little bit simpler. Recently, I was reading online and I came across the so-called dirty dozen, where the environmental working group, a bunch of people, crunched through a whole lot of data, probably using Python, and they released their dirty dozen, a list of the fruits and vegetables that have the most pesticides. And it's kind of crazy that they actually washed and peeled all of these foods and then tested them for pesticides. And the list looks something like this, where strawberries are apparently one of the worst offenders for pesticides. So let's create a list of the dirty dozen. But you'll notice that some of these are fruits like strawberries, apples, and other ones are vegetables. So how can we use our lists to still keep them inside the same sort of container, the dirty dozen, but somehow separate them out into fruits and vegetables? Well, we could just simply create two lists, fruits and vegetables. But these two lists kind of have a relationship, right? They're kind of related because they're all on the list of high pesticide foods. So how can we have lists within a list? Well, that's what's called a nested list. Instead of our original dirty dozen, we could create a new list called dirty dozen, and we set it equal to a list that contains two lists. It contains fruits and it contains vegetables. So now what effectively has happened is we've inserted this list inside here, and then we've inserted this list inside here. So we now have a list that contains two lists. And if I go ahead and print out this list, you'll be able to see its structure. And it looks like this. You'll notice that there's two brackets at the beginning and at the end. And the reason is because this is one list, this is another list, and this is also a list. So this is yet another way of using lists and just showing you the flexibility of this particular data structure. It's something that you're going to use a lot when you're writing Python code. Now that we've talked more about index errors, how to fix them, and also nested lists, you're ready to go to the next coding challenge. So head over there and give that a go. All right, guys, it's time for another code challenge. So head over to day 4.3 treasure map and take a look at what is happening here first. Notice how we've created three lists here for you, row 1, row 2, row 3, and they've got some blank tiles in here. And these were just created with emojis. So if you just search for emoji and you come across the list of emojis, then you can simply just copy and paste them right into your code like that. So depending on whether if you're on Windows or Mac, you'll see the emojis display a little bit differently, but it doesn't really matter what it looks like. All that we want to do is to create almost kind of like a chessboard or a map like this. So we have 3 rows, and then we create another list that includes all 3 rows. So this map is actually a nested list because row 1 is a list, row 2 is a list, etc. And it's all put inside a list. Then we go ahead and print it so that we add a new line in between each row. And the final outcome looks something like this. So if we go ahead and just run the code, you'll see that we have almost like a chessboard, or essentially a 3x3 square, right? And the sort of way that we're going to navigate this map is by using some indices. So we're going to say that this is column 1, 2, and 3, and this is row 1, 2, and 3. Now, if you've ever played chess, or if you play chess with a computer, you'll know that the different moves or the different positions are often mapped out using letters and numbers. So, for example, if you wanted to move to this square, then it would be B4, right? Or if you wanted to move to this square, then it would be H3. In our sort of 3x3 map, the way that we navigate is first by specifying the column, the horizontal column, and then we specify a number for the row. So for example, if I wanted to place my X marks the spot of my treasure, at this particular position, then it is 1, 2 on the horizontal, so column number 2, and then 1, 2, 3, row number 3. So I would write that as 2, 3. And if I wrote 3, 1, then it means I want column 3 and row 1. So I want to mark the spot here. So when you run the code, the idea is that you should be able to specify a location using that 2-digit system, and you should be able to place an X at that location. Now, in order to do this, it will need you to review what you know about lists, what you know about using the index to change a particular item in a list, which you saw in previous lessons. And the added complexity is here we actually have a nested list, so lists inside lists. So have a play around with this code, and that's the really important word. It's play, right? There's nothing that could possibly go wrong. Just try some different lines of code, try doing some different things, and see if it actually prints out the outcome that you want, where, when you specify a location, that's the place that gets marked with a capital X. Pause the video and try to give this challenge a go. All right, so let's try and solve this. So notice how at the very bottom of the code, I've got another print statement, which is going to show us the outcome of whatever code it is we write here. The first thing we probably want to do is get hold of the input position, right? We know that input always takes in a string. So even if we typed 23, that's not going to be the number 23. It's going to be the string with 2 and 3 inside the string, something that looks like this. Now we can use what we've learned in previous days and previous lessons to split that string so that we end up with a horizontal position and a vertical position. That way we know, well, which column are they interested in and which row are they interested in. In order to do that, we tap into this position. And in order to get the horizontal, which we mentioned is the first digit, then we go ahead and get the 0th item out of that string. Remember, the string looks like this. So the 0th item out of the string is this one. And then the vertical is going to be the one at position 1. Now, of course, these are still strings as they stand right now. We've just split up this 2-digit string into horizontal and vertical. So this one, if 22 was the input, would be equal to 2, and this one would be equal to 3. Now, once we've gotten hold of the horizontal position and the vertical position, then we can go ahead and start specifying positions in our list. So we know that we've got our map, right, which is here, this nested list. And remember that it contains 3 rows. Now, if we wanted to get hold of the first row, then we would write map 0. If we want to get hold of row 2, then we would write map 1 and map 2 to get row 3. Now, remember that this is the vertical position. So this is the one that we're going to be getting hold of. Or in this example, it would be the number 3, right? So we could say map passing in the vertical position. But there's just one problem, and I'll show you if I go ahead and print this map at the position vertical. Let's put in the example number, which is 2, 3, and you'll see that the problem is that list indices must be integers, whole numbers, not a string. Remember that we said these are still strings, so to convert them into integers, we use that integer conversion that we've seen before. So now both the horizontal and vertical are integers, and we can run this code again and see how it performs. Let's put 2, 3 in there, and we end up with the error that we learned about in the last lesson, which is index error. So it's out of range. So what's going on here? Remember that in our example, where the number is 2, 3, well, then the horizontal is the first number, so it's going to be 2. And then the vertical is going to be the second number, so it's going to be 3. And then we try to get hold of that particular row from our map. Now, if we pass 3 into our map, then you can clearly see what's going to happen. There's 0, 1, 2. There is nothing at position 3. There is nothing that has been offset from the beginning by 3, right? So that doesn't exist, and this is why we get our index out of range error. So what do we have to do instead? Well, we have to remove 1 from it to shift it to row 3, because that's really what we're interested when we're writing this here, right? We can do the same by substituting the 3 with vertical, so it'll work with any number. And now if I run my code again, type 2, 3, then you can see that I get no more errors. And it actually prints out a row that I've selected, which is row 3. Now, you can of course change these just to make it a little bit more clear to yourself what's actually going on here. Let's type 23 again, and you can see that this is what's being printed. Now, the next step is, once I've gotten hold of row 3, how can I get the horizontal tile? So the horizontal tile we're interested in is the second one, so it's actually this one. So when we write 2, 3, then it's this tile that we're interested in. So instead of printing out this row 3, which we selected by writing this code, we can save this as the selected row. And then inside the selected row, we can get to the tile at the horizontal position that was specified. So we could say selected row at the position of the horizontal -1. This works the same way because our numbers that we're entering here, row 1, 2, 3, or column 1, 2, 3, they don't start from 0, so we have to shift it down by 1 in order for it to work. So now once we've gotten hold of the selected row using the vertical, and then the selected tile using the horizontal, well, now we can actually change it. And the thing we want to change it to is a capital X. So now if I go ahead and run my code, then you can see it works just as the instructions want it to work. So here's our map. Where do you want to put the treasure? If I write 2, 3, then it will put the treasure on column number 2, row number 3. Now if I run this code again and I say, well, now I want to put it in column number 1, row number 3, then there it is. So this is now working for any possible combination that we come up with, as long as we're using the coordinates of our map. Did you manage to get it right? And did you write the code in a different way, perhaps? Because there's many ways of doing the same thing. And the easiest thing that I can spot right now is, what if we didn't need to separate this out into 2 lines? Instead of creating a selected row, we could simply just tag on this at the end, get hold of this particular row from the map, and because this is going to turn into a list, namely one of these, well, then we can simply just use another square bracket to specify the column. And then we set that tile to a capital X. So depending on which format you find easier to understand, you can keep your code either like this or like this. This is obviously a lot more succinct, but it depends on whether if this logic actually makes sense to you. So have a think about what happened here, and if you didn't manage to complete the exercise, then try to give it another go now. In the next lesson, we're going to tackle our final project of the day. So once you're prepared and once you're happy that you've understood everything that we've covered so far, then head over to the next lesson where we're going to get started building our rock, paper, scissors game. Alright guys, so now that we've loaded up all the knowledge that we need into our brains, it's time to tackle the final project of the day. And as I showed you in the beginning of the day, it's a rock, paper, scissors game that we can play with the computer. So the game starts out by asking you to type 0 for rock, 1 for paper, or 2 for scissors. So let's go ahead and type 2 for scissors. And then it's going to show you a graphic of your choice, scissors, and then the choice the computer made, which is rock. And of course, rock beats scissors, so you lose. What this game boils down to is some way of randomly making a choice between rock, paper, or scissors, and then comparing that choice that the computer randomly generated against your choice, and then based on the rules of rock, paper, and scissors, determining whether if you won, you lost, or whether if you had a draw. While I was looking around, I actually came across the World Rock, Paper, Scissors Association. And they have the official rules listed of rock, paper, and scissors. If you're not familiar with this game, it might be worth checking out this website. Here are the 3 shapes of rock, paper, and scissors. And then the rules are that rock wins against scissors, scissors wins against paper, and paper wins against rock. Having all of this in mind, head over to Replit/@brewery/rock paper scissors start and go ahead and just fork the starting project. Now you'll notice that in the starting project, I've already got the ASCII art for rock, paper, and scissors in here, and they're each saved to a variable. So what that means is that you can start out by just having a go at printing out, let's say, rock. And remember that these are variable names. They're not strings, so they don't need the double quotes around them. So let's run that, and you can see what we get printed is the particular ASCII art that I chose in my print statement. So this is already yours, but as you'll notice, there's no other logic that I've provided you. And you are going to rely on what you've learned in the previous days, and most importantly, what you've learned in today's lessons to be able to complete this challenge. And it's worth comparing the outcome against the game of rock, paper, scissors that I'll link to. There's a couple of things to think about, namely, how are you going to decide who won or who lost? How are you going to get the computer to choose a random shape, rock, paper, or scissors? And how you actually get this game to work in the same way that is demoed in this final version. I'm going to go quiet now, and I'm going to let you pause the video, and I want you to spend at least 10 or 15 minutes working on this. And if you get stuck, just try some things out, or maybe watch some of the previous videos in the day and just try to give it your best go and do a lot of struggling. Hopefully you're going to succeed, and once you're done, head back over here and I'll go through the solution with you. So pause the video now. All right, so we know that we've got all of this ASCII art, but for the moment, I'm just going to start off by pinning down the basic logic of this game. And it's really helpful for you as well if you start thinking about breaking down the larger problem, which is making the rock, paper, scissors game, into smaller problems that you can solve, like generating a random number between 1 and 3. So we have some sort of proxy for rock, paper, and scissors. And then maybe thinking about putting down the logic. Well, if the computer chose scissors and I chose paper, then I'm going to lose. Or if the computer chose rock and I chose paper, then I'm going to win. And putting that down on a flowchart using draw.io or something like that can make this challenge a lot easier as well. But without further ado, the first thing I need to do is to produce a user choice. Now, this is going to be the one that the user chose when they typed in a value. And in order to get the value from them, I'm going to need to use a input. And inside the input, I'm going to put the following prompt, asking the user, what do you choose? Type 0 for rock, 1 for paper, or 2 for scissors. Now, once I get hold of this input, hopefully, if the user is following my instructions, they're going to type some sort of number, either 0 or 1 or 2. Now that I've gotten hold of what the user wants to choose, the next thing to do is figure out what the computer is going to choose. So I'm going to make another variable called computer choice, and I'm going to generate a random number. So to do that, remember we have to import the random module, and then we can start using it to generate random whole numbers by using random.randint, and then the range is going to be between 0 and 2. Because this is what I asked the user to do. Type 0 for rock, 1 for paper, 2 for scissors. So the computer is also going to choose between 0, 1, or 2. Now that I've got the computer choice, I'm actually going to just print it out for now. Instead of printing out the actual shape, I'm just going to print out the number. So computer chose, and then let's go ahead and add a F string. And of course that requires the F in front of the string. So now if we just play the game as it is, remember that testing your app while you're developing it is really, really good practice. It picks up on the bugs that you make along the way instead of waiting until the end when you've done everything and then it doesn't work and you have to untangle all of the lines of code. At this point, I've already realized that it's actually not so great getting the user to type on this line. What I would much rather is to start a new line for them to type their answer on. So if I run the code again, then it should look a bit like this. My prompt is now here. So I'm going to choose 0 for rock. And then it tells me that computer also chose 0. So in this case, this would be a draw. But if I play this game again, you can see that the computer is probably going to choose something different. So I chose rock again, the computer chose 1, which is paper. So now we can start thinking about how do we compare these two choices and how can we define the logic of rock, paper, scissors. So I know that paper beats rock, scissors beats paper, and rock will beat scissors. So if 0 is rock, 1 is paper, and 2 is scissors, then 2 beats 1 and 1 beats 0. So that's very simple for us to check in terms of using if statements, right? We could simply just check, well, if the computer choice is greater than the user choice, well, then this probably means that the computer wins. But this is not true in all cases, right? Because if the computer chose 2 for scissors and the user chose 0 for rock, then the user should win rather than the computer winning. So we actually have some exceptions to this rule. How can we catch the exceptions before we go down to this level of generalization? Well, we could, instead of using this as an if, we use this as an elif, and we create another if statement which says, well, if the user choice is equal to 0, so if the user chose rock and the computer choice was 2, well, then this means that in this case, the user actually wins. Now, if we're thinking from the perspective of the user when they're playing this game, then they don't really care if the computer won or the user won. They want to know, did they win or did they lose? So let's change this wording a little bit. We'll say, instead of user wins, we'll say you win. And if the computer wins, then we'll say you lose. So now if we run our program and test it out, so let's say I'm going to type 0 for rock and the computer chooses 2, but we actually get an error. It tells us that the greater than comparison is not supported between instances of int and string. What's going on here? Well, remember that we get our inputs as a number, but the input is always going to be a string. So we want this to be a number, then we're going to have to wrap it inside an int. So now we turn it into a whole number. Now, this might be a good point to address, well, what should happen if they typed something that wasn't 0, 1, or 2? Well, if they typed 34? Well, then naturally they should probably lose, right? So we can add an else statement addressing this situation. So we could say else, we just print you typed an invalid number, you lose. Cool, so that sorts that out. Now let's run our code again and see if it works. What do you choose? Type 0 for rock. I'm going to choose rock again. Computer chose 0, and it tells me that you typed an invalid number. Well, actually, 0 is not an invalid number. So what's going on here? Well, it's because it didn't fit this criteria. So I had 0, computer had 0, and it didn't fit this criteria because 0 is not greater than 0. So it basically defaulted to the final else statement. But what's actually happening here is that that was a draw. Computer chose rock, I chose rock. That's a draw in the official rules of rock, paper, scissors. So how do I catch that? Well, I could create another elif statement which says, well, if the computer choice is equal to the user choice, well, then we're going to print it's a draw. Now let's test our app again and see if there are any other situations where our code is not behaving properly. I'm going to choose rock again. Computer chose rock as well, and I get it's a draw. So that's pretty good. Now, if I choose 0 and the computer chose 2, then this is going to be the statement that gets triggered and I win. So that's pretty good. Now, what if I chose 2 for scissors and the computer chose 0? Well, in this case, rock beats scissors, so it should actually say I lose. But instead, it says you typed an invalid number. So it defaulted to the else statement again, because this particular situation is not caught by any of these statements. So what do we have to do instead? Well, we actually need another elif to say, well, if the computer choice was equal to 0 and the user choice was equal to 2, well, this means that rock beats scissors, so I lose, and the computer wins. Now, the final one that we need to catch is this case. If I type 1 for paper and computer chooses 0 for rock, it again defaults to the else statement. Whereas in fact, in this case, it should tell me that I won. So what's missing here? Well, it's the partner to this particular statement. If computer choice is greater than user choice, then I lose. But on the other hand, if the user choice was greater than the computer choice, then I actually should win. So now the final thing we might have to fix is this else statement now actually never gets called, because this is what happens. So let's say that I choose 456. It tells me that computer chose 2. I win. What's happening here? Well, it's actually this particular line that's being carried out. User choice is greater than computer choice. This is not what we want. We want it to default to you typed an invalid number, you lose. So we can't actually just use else in this situation. We actually need to provide a condition. We're going to use elif to check if the user choice is greater or equal to 3. Now, the computer will never choose anything other than 0, 1, and 2, so we don't have to check that one. But the user could choose something above 3 or below 0. So we can use an or statement to catch this. Or if the user choice is less than 0, well, in this case, you typed an invalid number, you lose. But that's not all that we have to do. If we hit run and we again type some extraordinarily large number, you'll see that it still says computer chose 1, you win. What's going on? We have this statement that should catch this situation, but it's right at the bottom. So it's not going to be checked until one of the previous ones are checked. Namely, it's one of these that's going to be the problem. So what we have to do is we have to move this statement above all the lines so that we first check if the user choice is greater than 3 or less than 0. And if that's not true, do we actually continue checking to see who won the game? Now, finally, we can run our code, type an invalid number, and get you typed an invalid number, you lose. So now that we've actually got our logic all sorted out, the next step is to include our images. And to do that, we have to somehow match it up with these numbers we have, right? 0, 1, and 2. Now, there's many ways that you could do this and you could solve this project, but the easiest way is probably putting the game images into a list where we have rock as the first one, paper as the second one, and scissors as the last one. So we're using the fact that lists have a order that is always going to be followed. So we can now get hold of the rock picture by getting game images 0. We can get scissors by doing game images 2, and so on and so forth. And we can match those up to our choices, the user choice and the computer choice. So when the user chooses a number, then we're going to print from the game images, and we're going to use our little square brackets to select the image we want from this list. And the one that we want is going to be based on the user's choice, right? 0 for rock, 1 for paper, 2 for scissors. So we're going to put user choice as the index to pick out an image from game images. Now, down here for the computer choice, instead of printing the number that the computer chose, I'm going to delete that and add a little colon. So that way it's going to show computer chose, and then I'm going to print the image of the choice that the computer made. So I'm going to add another print statement. I'm going to tap into the game images, and then inside some square brackets, I'm going to use the computer choice, which is going to be between 0, 1, and 2, as the index to pick out the corresponding image from my list game images. So now we're finally ready to run our code, and I'm going to choose 0 for rock, and the computer chose paper. So paper beats rock, I lose. Let's try this again. I'm going to choose scissors, and computer chose scissors, it's a draw. Now we have completed the project by using everything from lists to randomization to variables to if statements and a whole lot of logic. So how did you get on with this project? If you struggled, this is the time again to go back to it and maybe map things out using a flow diagram, or try to run the code using Thonny to see how it does it step by step. But the important thing is that you got to write your own code and you got to make it work. And this is the only way that you'll understand what's going on, so that you can continue on. And as things get harder, you'll be able to learn more because you've already understood all of the previous knowledge. So I hope you had fun with me today, learning and building, and hopefully I will see you tomorrow, bright and early. So that's good night from me for today.